Now subnetting. So we learned how to define and find the valid host ranges used in class A, B and C network addresses by turning the host bits all off then all on. So you are defining only one network. What happens if you wanted to take a one network address and create six network from it? So you would have to do something called subnetting, because that's what allows you to take one larger network and break it into a bunch of smaller network. For example, suppose you have a class B network. Now class B network means what? You are having almost 65,000 IPs. 65,000 IPs, that means you can use those 65,000 IPs on different machines. Now those all different machines will be connected together because they will consider as a single network. They will be connected together. That means they can do communication together, they can send data to each other, and not even send data to each other, they can send broadcast to each other also. Now broadcast means what? Unwanted, we can say unwanted information also. Now for example, suppose you are having 65,000 machines in your company. That does not mean like they are in the same department or in a same process. You may have different departments, different process. Like for example, you are having a you are a big company of which can have a 65,000 machines. Now 65,000 machines or 60 machines or 60,000 machines or maybe 50,000, 30,000 is too much. That means you are a big company and you are having a whole campus of yours. Whole campus, that means with that campus you are having different buildings of different department. That means you are not working on only one stream or one process, you're working on multiple different processes. Like you're working on you're having a sale department, you're having marketing departments, different departments. You're owning the company for communication, you are having a company for oil, you're having a company for textiles. So you're having a different departments maybe. Now those different departments rarely do connect to each other. They do not regularly, they don't connect to each other, they don't do communication together, and they don't do communication together regularly. Now putting them into a same network, which is all connected into same network, is not good idea. It is not manageable. It is not able to you will not able to manage properly. And if you want to do troubleshooting, it is also not good for that also. Like if you face any problem in one side, it will reach to everyone. Like you are having a problem on one department building, that means it will go to all the departments of your company, because they are together, they are connected together. So for managing properly, for troubleshooting properly, and the most and the big reason is to breaking the broadcast. Now broadcast means what? If suppose you are having one department in one building and there is one DSCP server. For example, DSCP server means it is used to assign IP addresses. Now first time it will assign IP addresses to everyone. Now when the IP expires, the client machines again try to connect the DSCP server. So mostly those client machines sends the broadcast. Now broadcast request means it will go to everyone. From the single client, it will go to every machine in your network. Remember, when I say network, that means I'm saying all the 65,000 machines. So your network broadcast will go to all, and because they are in single network, it will go to uh, every machine in your network, whether they need it or not. So it can create a very storm of broadcast. It can create a broadcast storm, and when the broadcasts are increasing, that means your network performance will decrease. Remember, broadcasts are not good for our network, so we have to minimize the broadcasts. So that is also the reason to break these broadcasts to going from one to another department. We use this subnetting. So we use the subnetting to divide these single network into multiple smaller networks. This is the basic job of subnetting. Very simple. It do what? It divide one single network into multiple subnetworks, and that is what subnetting is all about. For example, you are having these different departments. Now different department means you are having a department here, you are having a department here, and here, and here. Now suppose you are having four different departments and you are having a single network. So what you can do here, you can divide this single network into multiple different networks. Single network, for example, you are having 192.168.1.0. That means you are having what? Total 256 IPs. Now if you put the 256 IP within this, that means you can put some IPs here, some IPs here, some IPs here. Like some machines are here, some machines are here, some machines are here, some machines are here. Now if you put them, if you give them directly all the IPs, if you divide this IP directly to all of them without doing the subnetting, that means these all departments will remain in same network. Now these are different departments, but when you use the same IP, when you use the IP without subnetting, that means they will remain in a single network. Now whatever happen in this network, it will affect all the other networks because they are in single network and they are connected together. So if they are connected together, so they can do what? They can affect each other. For example, suppose you have virus, you in this network we have a machine, and in that machine we have virus here. So the machine is affected by the virus. Now what happened? The virus will spread in all over the network, that means in all over the departments. The problem remains not here because it is affected only this network, but because they are in single network, it will affected all the networks in all the department in the machine, in our network. So if you not do the subnetting, then it will affect everyone. One more thing, it can do what? It can send the broadcast network to multiple networks. So if you are having a network, like if you are having departments, which is different departments, like these four departments where you have 120 machine here, you are having 30 machines here, 12 machines here, 60 machines here in this department. Now you are having an IP range of this 192.168.1.0. This is class C. That means you can have IP of total 256. Now you are having a 256 IP in your class C network, and how many IP you need is what? 120, 30 is 150, then 160, 150, and one this is like a 110, 120, 22, 122 IPs you need, and you are having what? 256 IP. That means you can assign every machine single IP of your network. Now the problem is what? If you use IPs, when you assign IPs directly to these machines without doing any subnetting, that means they will remain in single network. Now they are connected through the switch. That means they are connected through the switch, and that means what? They can do communication to each other. Now they can do communication to each other. That means if anything sends from this network, it will go to any other subnet, any other department, we can say. Now the problem is what? I'm saying only I'm giving an example of a very small network, but if it is a big network, that means what? you can get the problem from one network to pass to the other network, like other departments. For example, if some machine sends a broadcast for this department only, remember, only for this department, the broadcast is not for other departments. But still, because they are in single network, they can get the broadcast. That means the broadcast will go to these departments. And when the broadcast increase, your network will get slow. One more thing, if you get any problem here in this subnet, then it will be difficult for you to find the subnet, find the problem, because they are in same network, they are in single network. You will get a problem for troubleshooting. And also, if suppose your one machine of this subnet gets the infected by the virus, so the department, this department machine infected with the virus, so because they are all in a same network, your other machines will also be affected by the virus, because it can reach there and it can do what, affect other machines also. Now the solution for this, like to management, to troubleshoot, and to divide the broadcast, the solution is what? Subnetting. Now what we can do, we can divide the subnet into multiple different small subnets. Like we are having a single subnet by default, and that is what it is having total IP of 256 in this. Now what we do here, we can divide it into multiple different subnets. Like we want 4 subnets, 4 departments, and we are having 4 departments. We need one subnet for every department, so we can do that. We can divide it into 4 different subnets. Now remember, when we do the subnetting, when we divide a single network into multiple small networks, then what? These networks will become separate. Remember, the rule of IP is what? If any machine belongs to any other network, they will not communicate. So that means from this network, the other network machines will not able to communicate. The communication will be break. The communication will break. That means anything remove, anything goes from this network, or if from this department or this subnet, will not reach to other departments. Like if any problem comes here, then it will be easy for us to find out the problem, because we know if it is here, that means it is affecting only this subnet, only this department. It will not affect other departments. So it will be very easy for us to find out the problem, and the management will also be easy. And if any virus comes on one department, one subnet, it will not reach to any other. If we have a broadcast, if we have a broadcast from one department, like in this department, in this subnet, if any machine is sending a broadcast for these its own department, it will not reach to any other department after doing subnetting. Remember, after doing subnetting, they will be separate networks and they will not communicate. Now if you want to communicate to each other, remember, these are same company, these are department of same company. So sometime they wants to send mail to each other, sometime they wants to some files to each other. So they should not, they can do also that thing. Now if they want to do that, then we need what? Router. We need router, because two different subnets can only be connected by routers. Other than that, you cannot connect two different subnets. So switch can only connect same networks, it cannot connect two different networks. If you need to connect two different networks, you need router. So if you convert this single network into multiple subnetworks, then these networks, subnetworks, will not communicate to each other. So if someone wants to send mail from this network to this network, then his mail will go to the switch, and then it will go to the router, and then router will send the data to this subnet, and then the reply will go to the router, and then router will send the reply to this subnet. So if you want to connect the subnets, different subnets, then you need router. So when you do the subnetting, that means you divide single network into multiple subnetworks, then they will not do communication until you want to do them. That means you will connect the router to connect these different subnets. Now what is the router do? So basically router does not broadcast. That means if anything goes from this network, remember they are not connected, so the router is connecting them. Now router will never pass a broadcast. So any broadcast comes from any other network, it will not go to other network, it will reach till the router, and router will discard the broadcast packet, and it will not send any broadcast to any other network, it will remain in the same network. But still if you want purposely send a data to one network from other subnet, one subnet to other subnetwork, then it will go through the router, but the broadcast will not go. And viruses also use broadcast, and if any problem comes, they will also try to infect the other machine through broadcast, and the router will not allow to pass the broadcast from one subnetwork to other subnetwork. So this is why we do subnetting, and this is how this is why we need subnetting, and this is the meaning of subnetting, like dividing single network into multiple subnetworks. Now how we will do this, that is also important. So for example, I'm giving an example. In a small network, we are having this network, class C network. Now class C network and slash 24. Now what is this slash 24? This thing is called CIDR value. Now CIDR value means classless interdomain routing value. This value indicates, very simple, this value indicates what? It indicates value, it indicates enable bits in subnet mask. It only indicates that how many enable bits we have in subnet mask. Now remember, this 192.168.1.0 is what? Class C IP address, and it is a class C network. Now class C network means the default subnet mask for the class C network is what? Default subnet mask will be 255.255.255.0, and that means what? If you see it in bits, that means all the bits of here is on, that means 8 bits are on, dot 8 bits are on, dot 8 bits are on, dot the last 8 bits are 0. So actually how many bits are enabled here? 888, and that means what? We are having 24 bits enabled. So if it is class C, then you will see 24. If it is class B, then you will see 16 here. If it is class A, then you will see 8 here. So this CIDR value indicates that how many bits are enabled in subnet mask. Now this one is the default one. Now remember, the default means you cannot change this. I said default you can't change, but you can change the rest of the 0 bits in subnet mask. Now remember, subnet mask indicates what? The network part and the host part. And in the subnet mask, if all the bits are on, that means it is a network. And if any bits is off, that means it is network. For example, if this is a class C, then the subnet mask, if I convert it into binary, so 1 2 3 4 5 6 7 8, all the 8 bits are on. Then 1 2 3 4 5 6 7 8, this all bits are on. Then 1 2 3 4 5 6 7 8, these all bits are also on. And then the last 8 bits are off. So 1 2 3 4 5 6 7 8. Now the default is this, and I cannot change this. I cannot disable any of these bits, but I can use these 0 bits. This 0 bits is mine, and it's also indicate what, how many networks, how many hosts you have. This subnet mask also indicates how many network and how many hosts you have. For example, we know that by default, if you are having a class C, that means 24 bits are on. And that means what? If you want to know how many networks you have, that means 2 raised to, you do what? 2 raised to 24. Now, because you are not able to use the reserve bits, so you use what? Minus 321. And for host, you do what? You do 2 raised to host bits. So 2 raised to host bits are what? 8. Because you have only 8 0 bits available. And that means you get what? You get 256 host. And that is why in class C1 network you get 256 host, because in your subnet mask of class C you are having only 8 bits 0. Now this 256 host is your. You can do anything. Now you can do anything means what? You can divide these 256 into multiple subnetworks. Now how you will do this? So how we'll do this? How we will divide this single network into multiple subnetworks? Now remember, we can't change this default one. So this is what default, and we cannot change this, but we can change this. Now what we need here? We need 1 2 3 and 4 different subnets, 4 different networks. Remember, we need networks. Now in subnet mask, what is the network? 1. If the bit is enabled, then it is network. If the bit is 0, that means it is host. Now if I need 4 extra networks apart from default, now this is the default networks we have in class C. That's fine, we can't do it anymore, this one. And that is why we are getting this network here. And in this network I'm getting 256 host. So now what? I want to have more networks in this default subnet. So this is my default network, and in that default network I need more subnetworks. Then what I can do? I can enable these 0 bits to get more networks. Now when I enable these 0 bits, so my networks will increase, but my host will decrease, because the zeros will decrease. So my host will decrease and I will increase my networks. But remember one thing, you cannot change the default one. Now how many networks you will get by enabling the bit, and how many hosts you will get by enabling the bits, that depend on the same calculation, that 2 raised to the network bit and 2 raised to the host bits. So if you want the network, then you will raise 2 raised to network bit. If you want host, then you will raise 2 raised to host bit. And the network bit is what? The bits which is enabled, and the host bits are what? The bits which is disabled. Now for this example, I need what? How many networks? I need 4 different networks. Now 4 different networks, that means I want to have what? Network bits. Now how many network bits I need to get these 4 networks? Now you know the 2 raised to formula. If you raise 2 to 1, you will get what? You will get what? 2. Now if you raise 2 raised to, so if you raise 2 raised to 2, you will get what? 4. And if you raise 2 raised to 3, you will get 8. If you raise 2 raised to 4, you will get 16. Then this will go on. Like if you raise 2 raised to 5, you will get 16. Then if you raise 2 raised to 6, you will get 32. Oh, sorry, I think I made a mistake there. This one is 32, and when you raise 6, you will get 64. And when you raise 2, when you raise 2 to 7, then you will get 128. Then when you raise 2 to 8, then you will get 256. Then when you raise 2 to 9, you will get 512. Then when you raise 2 to 10, you will get 1024, and then so on. So when you raise these bits, you will get this. So like this. So this is what you get. So it is like raising 2 to the bits. Now remember, the on bits means what? If the bit is enabled, that means what? We can say if the bit is on, that means it is what? It means it is network. And if the bit is 0, that means it is host. So if the bit is on, that means you are getting what? Network. And if the bit is off, you are getting what? Host. And this is a table. We can select. Now you have to memorize it, that what that means. 2 raised to 1 means 2, 2 raised to 2 is 4, 2 raised to 3 is 8, 2 raised to 4 is 16, then 32, 64, 128, 256, 512 and 1024. then 2 raised to 11 will be 2048, then 2 raised to 12 will be like this, and so on. So it depends how many bits you can enable. Now we are having lots of bits here, we are having 32 bits. So it depends like how many bits you want to enable and how many bits you want to disable. Now in this case, what I want here is 4 different networks. Now 4 different networks, that means I want this enable bits. Now enable bits, how many I want? So I can see the table here that 4 networks, that means for 4 I need to enable 2 bits. That means when I enable 2 bits, that means when the 2 bits gets on, I will get how many networks? 4. And that is what I need here. I don't need 8 networks, I don't need 2 networks, I need 4. So 4 means what? I need to enable 2 bits. So if I enable 2 bits, that means I will get 4 networks, and what I need here. Now I'm not talking about host, I'm talking about network. So I will do what? Enable the bits. Now enabling the bit means what? This is our default subnet mask, which is in binary. It is what? 11111111, and the last 8 bits are 0. But remember, this one is default. So I cannot change that default. Default will remain same. So this 1 2 3 4 5 6 7 8 dot 1 2 3 4 5 6 7 8 dot 1 2 3 4 5 6 7 8 we cannot change, because this one is what? Default. So this one is default and we can't change it. Now what we can change is this 0. So we can change these 0 bits, and these 0 bits belongs to us. So apart from the default, we can do change anything else. So the default we can't change, but this one we can change. Now how many networks I need? I need 4 networks. Now 4 networks, that means these bits are all 0. Now I need what? Enable bits. So I want to enable how many bits? I want to enable 2 bits to get 4 networks. Now how I will do that? I will enable only 2 bits and I will leave the other bits as 0, which I don't need. Now for enabling the bit, it is not like I can enable from anywhere like this. In subnet mask, remember I told you it is not possible to do this by enabling any bit from anywhere. If you want to enable any bits, that means on bits will always come from left to right side continuously, and that is why you can see all these bits till the 24 bits, they all are coming from the left to right continuously. And if you want a 0 bits, then they will come from right to left side continuously. So they will be continuously going. It will not do like you can enable anyone from anywhere. You cannot do that. You can only enable bits continuously, and you can only disable bits continuously. Enable bits will come from left to right continuously, and the disable bits will come from left to right to left continuously. I need now, for this example, I need 2 enable bits. So what I will do here, I will enable 2 bits. 1 2. Now 1 2 means what? 2 bits are enabled from the 8 bits. Now how many bits I will remain? So 2 3 4 5 6 7 8. That means how I will remain with 1 2 3 4 5 6 6 0 bits. So I enable 2 bits and the remaining 0 bits will be 6. Now that means what? That means what? Here if you see in this case, in the default case, I know the total number of network is what it is based on the class C, the total class C, because we are not changing anything here. That is what 2,019,52 or something like this. I don't remember exactly. Okay, let me calculate it. Class C. Now this is the network you will get in total class C. What? 222,097,152, because these are the bits which is enabled, total bits enabled here, and these bits represent what? The default class C bits, and that means what? It is represent the whole class C range. So the whole class C range we get what? This number of network. Now how many hosts we get in class C single network? That means we can say host per network. So host per network, that means what? We get 8 bits. We remains with 8 bits, and 8 bits means we can see the table here means 256. So in class C single network we'll get 256 host. Now when you do the subnetting here, now what happened here? I will leave the default. That means we'll not count this default networks. We will leave it. So we will leave this default network. Now we are talking about the network which we have. Now the network which we have is the only one network of class C, and in that network we have total 256 hosts. Now what we did, from this 256 hosts, that means from these 250, these 8 zeros, we enable 2 extra bits. Now that means what? Now we get extra networks. Now how many networks? 2. That means 4 networks. So we get 4 extra networks, and that what we need here. What we need here? 4 extra networks. Now how many hosts we get per network? So if you see, the remaining zeros are now 6, and 6 means we can see here 64, because 2 raised to 6 means what? 64. So we are getting 64 here. So after doing the subnetting, we are doing the subnetting in this 256 host. This one is default, so we are not doing anything here. So what we are doing here is in this total host. So because we can't use the default one, because we don't have all the networks of class C, we are having only one network of class C. So in that network we are having what? Only this 256 host. Now what we are doing here, we are dividing this 256 into 4 different networks, and in each network we are getting what? 64 host. So in each network we are getting what? 64 host. It is like dividing this 256 into 4 parts, and each part will get 64 IPs. Now what? We need this. So we need 4 different departments here, and for every department we need some IP addresses, and that what we do, we did divided into 4 networks. This single network which consists of 256 hosts, now we divide it into 4 different sub networks by enabling the bits. Now what is the meaning of enabling the bit means? how we use this in the machine, like how we can use it in machine. So simple. When we give IP address to any machine, that means any machine, that means any of these machines, like any of these 60 machines or any of these 12 machines, 30 or 8 machines. So what we do, we will give the IP address like this, like 192.168.1.1. It will start from 1.1. This 0 we can't use, it is the network address. So we can't use the network address. We will start from 192.168.1.1 and so on. So whatever IP we will give what? We will not give the default subnet mask. Remember, the default subnet mask is this, and this is the binary of this default subnet mask. So default subnet mask says that the whole IP of 256 is in same network, but we divided these networks into multiple subnetworks. And now we can use these 4 different subnets into these 4 different departments. For example, I will start from let's say this one is having 50 machines, this one is having 40 machines, this one is having 60, this one is having 30 machines. Now what I will do, I have divided this into 4 parts and I can use it on these machines. Now remember how we use it. So when we assign any IP to these machines, we will not use this default subnet mask. It will come automatically, but we will not use it. So what we will use is this subnetted mask. Remember, it is called what? Subnetted mask, because we did it and we divided it to 4 subnets. And how we did it? We enable these 4 bits. Now when you don't have this enable bits, the default subnet mask will be like 255.255.255.0. But now it is changed. So now what it is become is 255.255.255. This is the default one, we can't change. But now what I did here, I enable this 4 bits. Now we did what? We enable these 2 bits. That means what? Now we can't write here 0. We cannot write it 0 here. And that means what? When we enable these 2 bits, we have to count the value of these 2 bits. Now what is the value of these 2 bits? So if you say the first bit value is what? 128. Then the second bit value is what? 64. Then all the other bits are 0. So here what I will do, I will add so here now we can't use 0 because the 0 is now changed. We enable these 2 bits. Now remember, these 2 bits means I will give you the whole value of those bits. So the first bit value is what? 128. Next bit value is 64, then 32, then 16, then 8, then 4, then 2, then 1. Now these are the all 8 bits. 1, 2, 3, 4, 5, 6, 7 and 8. And we enable these 2 bits. So when we enable these 2 bits, that means we add these 2 values. And when we add these 2 values, the 0 will become 192. So this is your default subnet mask where the all bits are 0, host 0. So it will be 0. It will be 0. But when we enable these two bits, so it will become what? 192 255 dot. Now the value of those two bits is 128 and 64, and it will be like 192. And if you write it on CIDR value, if you write it in CIDR, so it will be like slash. If you want to write it like in CIDR value, so it will be slash. Now remember, this default bits are what? 24, and what we did, we enable extra 2 bits, so it will be 24 plus 2 is 26. But remember, these CIDR values only for writing. You can't use it in machine, in normal desktop machines. So what we use is this subnet mask. So we will use this subnet mask on all the machines when we try to assign the IP. Now when you assign the IP with this subnet mask, machine will calculate itself that how many networks are there and the IP is belonging to which network. So for example, I want to assign the IP here in this first network. So what I will do, I will start it from this 192.168.1.0. Let's say I will start it from 0. Now why I'm starting it from 0? Because this is the first IP. Now how many IPs I can go here? So I will go till this is what network IP. Actually I can't use this IP. This is what the network IP, where the host bits are 0. So we can't use this IP. So the valid IP which we can use will be 1. And then it will go till what? I can use what? In one network there are 4 networks, like 4 blocks, and each block size is what? 64. So the block size will be 64. That means I can go up to 64. Now 64 means 192.168.1.0, from 0 to 64. That means 64. Now remember, because we are starting from the 0, so we can't go till 64. It will become 65. So you have to minus 1 to go to 63, because from 0 it will go to 63 for 64. So this will be the first IP of the first block. We are having 4 blocks, and this will be the last IP of the block. Now the first IP we cannot use because it is a network IP. We can use this IP, but we cannot also use this last IP. This IP will consider as a broadcast IP. So remember, in any network we can't use the network IPs and the broadcast IP, but they remain in a network, but we can't use them in our normal machine. So we can use what? We can use the IP from 192.168.1.1 till 192.168.1.62. We can use this range, and we can assign any of these machine IP here with the subnet mask. Now which subnet mask we will use? We will use, this is the default subnet mask of class C. But now what we did a subnetting, so we don't use this. We will use 192 here. We have to manually change the subnet mask because it will not change automatically. You will change it manually. Now when you use this subnet mask with all these IPs to assign to machine, the machine will understand that this is the first network of 4 different networks we have. With the subnet mask, machine automatically understands that we have 4 networks, and these IPs are of the first network. and this is the network IP of the first network, and this is the broadcast IP of the first network. Then from the next, for the next department, what I will do, I will start from the IP where I left. So I left on 63, that was the last IP of the first subnet. So 64 will be the network IP for the next subnet. So this will be the IP for the next subnet, and now this is what the first IP of the subnet, so it will be considered as a broadcast network IP. So we can't use that network IP, so what IP we can use? We can use 65, and we can go up to what? Again 64, that means 192.168 1.64. Now after 64, when you add 64 into 64, what you will get? You will get 128. Now remember, 128 you can't use, you have to go 1 minus, because remember we are using what? 0. So what? It go up to 127, and this will be the last IP of the network, and it is considered as a broadcast. So what IP you can use is 192.168.126 till 126, and 127 will be the broadcast IP for your subnet. And again, when I assign the subnet mask to this network, what I will do, I will again use 255.255.255, but I will not use the default one, I will use 192. So the first subnet I assign for this department, that means I'm using in this department, that means all the machines are in this department, I will use this IP within this range with this subnet mask, and the machine will understand automatically that we are having how many networks, and what is the network IP for the network, and what is the broadcast IP for the network. Now we ended on 127 for the second subnet, so it will start from 128. Again, this is the first IP, it's a network IP, we can't use, so we can use it from 129. Now again, when you add 120 64 in this 128, then you will get what? To 190 192, you will reach to 192, but because we are using the 0, so we can't say 192, we have to minus 1 and we'll get 191, so we reach up to 191. And this will be the last IP, so it will consider as a broadcast IP. So the last IP which we can use will be 192.168.1.190. This is the last IP which we can use. Now when I assign the subnet mask to this network, again I will use 255.255.255. I will not use 0, I will use what? 192, because what? We did the subnetting. Now the next network will start from 192.168. One dot, we ended on 191, so it will start from 192. This is the first IP, so we can't use it, it will consider as a network IP. So it will be considered as a network IP. Now you cannot use that IP, so the usable IP will start from 193, and then we can go up to 192, 168, 1 dot. Now remember, under 192 you will add 255, you will add 64, and it will reach to 255. And remember, this is the last IP of class C network, and this will be the broadcast IP. So the last IP which you can use will be 192.168 1.254. This is the last usable IP of the last subnet, and the subnet mask you will give on these, on the all machine of this network, will be 255.255.192. So when you do like this, and when you use this subnetted mask, now how we know the subnetted mask? Because we did what? The calculation. We did the calculation in a book. We did the calculation in a book, and then what we did, we added here. So this 192 means we enable 2 bits, and 2 bits means we get 4 networks, and in each network we are having 64 machines, 64 IPs. And when you assign all these IPs, this is the first subnet, this is the second subnet, this is the third, this is the fourth subnet. So when you assign any IP of these subnets in these departments, that means what, you will these machines will automatically understand that what you are doing is what you did, what, subnetting, and what, this IP is what, first subnet IP, or this IP is third subnet IP, or this IP is second, or this IP is fourth subnet. So what calculation we did it on book, when you give this subnet mask in a machine, machine will did it automatically. It knows that what you want to say and what you want to do. Now after doing this, these machines will be separated, and they will not able to communicate to each other because they are separated network. And then if you want to do communication, then you need what, router. So you have to connect router to do the communication, otherwise they will not connect to each other. So this is what a subnetting, and this is how we do the subnetting. We do the subnetting very simple by enabling the host bits, because on bits in the subnet mask is what, network, and 0 bit means what, host. So if we want more networks, then we want more 0 1 or enable bits, and if we want more host, then we want what, more disable bits.